everybody. I'm Sergeant Don Lawn alongside
Sergeant Donnie.
And we are going to demonstrate Newton's first law and friction. Now we're going to do this by playing hockey. And this is an object at rest, as you can see. This tennis ball. And Newton's first law states that an object at rest will not move unless acted upon by an outside force. So Donnie's going to show us how to do this here. And this tennis ball is at rest, and he's going to act on it by an outside force. And watch what happens. Oh, he's getting the power stance. Oh, he killed that one! Thank you for that demonstration, Donnie. Now, we just showed you what an object at rest does once it's acted upon by an outside force, but what about what happens when the object in motion? How does it stop? Well, Newton's first law also states that an object in motion will not stop unless acted upon by an outside force. So we're going to demonstrate this. I'm going to play goalie, and Donnie's going to shoot this tennis ball, and it's going to be moving, and I'm going to be the outside force acting upon it. And here we go.
Where do you want me to hit you, Sergeant Don Lawn?
Where it counts.
Where it counts. Right in the glove. Oh. Well, as you can see on the previous shot that I took, the ball was moving with a high velocity. When the ball struck Sergeant Don Lawn in the glove, the ball was abruptly stopped by an outside force, therefore decreasing it to 0 meters per second velocity.
I'm Sergeant Don Lawn,
Back with Sergeant Donnie.
and we are here for the second physics principle of the day, and that is friction. As you can see, we're in a garage here, and everybody knows what the garage floor is like. Concrete with a little slickness to it, and this is a composite hockey stick, so it's also very slick on the bottom. So this is a low friction surface, so this tennis ball, when we shoot, is going to have a very high velocity because there is less friction between the stick and the ground and the ball on the ground. And Donnie's going to show us how this is done.
As you can see, the stick slid along the ground with a lot higher velocity than on the carpet,
which we're going to demonstrate next. Back in the basement with Sergeant Don Lawn and Sergeant Donnie. This time we're going to shoot off a much higher friction surface, and that would be the carpet. The reason the carpet has a higher friction is because compared to the garage floor is hard and sturdy, so it doesn't have any give, and the composite stick slides right nice and smooth along, and because the concrete exerts a force back up on the stick. Down here, the carpet is softer, so the stick, or it gives, so the stick gets caught up in the carpet more. So therefore, the velocity of the blade of the stick is going to be less, which in turn is going to make the velocity of the shot less. And Sergeant Donnie over here is going to demonstrate this for us. And yeah, as you'll be able to see, this shot will not be near as hard as the shot on the concrete garage floor. And it's that time of the hour, Sergeant Donnie. And unfortunately, we are out of time here with Physics Boot Camp. But let's just review a little bit of what we covered today. So first we talked about Newton's first law, also known as the law of inertia. And an object at rest, like the tennis ball, will stay at rest unless acted upon by an outside force. And then once it's in motion, it will stay in motion unless acted upon by an outside force, again, to stop it. And we also talked about friction.
Friction was the second topic we talked about today. And as you can see, a much harder, smoother surface clearly has less friction than a surface such as carpet, which is a more rough and uneven surface. So a shot taken off the harder, smoother surface will have a higher velocity than the shot taken off of the rougher, more uneven carpet.
And we'll see you next time on Physics Boot Camp.